Welcome, dear listener, to this quiet moment, a space where the vast expanse of the cosmos meets the gentle stillness of your own inner world. As the day begins to fade and the edges of your awareness soften, let us embark together on a serene journey into the profound mysteries that shape our understanding of existence itself. There are revelations unfolding every single day, insights into our universe that gently push the boundaries of what we once thought possible, brought to us by dedicated minds exploring the very fabric of reality. These discoveries often give rise to new ideas, new perspectives so compelling that they invite even the most grounded among us to pause, to breathe deeply, and to simply allow our minds to wander into the realms of the truly extraordinary. Tonight we will explore a handful of these wondrous theories, not to stir your thoughts, but to offer them a new, tranquil landscape upon which to gently drift as you prepare for a peaceful sleep. Allow your mind to release its hold on the day's concerns, and instead, let these cosmic tales softly cradle your awareness, guiding you towards deep relaxation and a restorative rest. We begin by looking at a theory so fundamental, so encompassing, it reshapes our very idea of home, inviting us to consider whether we might in fact be living within a black hole. For decades, the Big Bang Theory has stood as the cornerstone of our cosmic origin story, a monumental discovery that illuminated the genesis of our universe. Yet, for all its groundbreaking insights, it has also presented a persistent recursive question, one that has occupied the minds of countless physicists and research scientists. Imagine, if you will, the early days of scientific inquiry, when sensitive measuring devices were first pointed towards the vast, silent canvas of the sky. These instruments began to pick up on a faint, ubiquitous whisper, the cosmic background radiation, a relic, a soft echo from the universe's earliest moments. This discovery, like a tender brushstroke, painted an enlightening picture of the original flickers of time, revealing the primordial warmth that once enveloped everything. It suggested a universe born from an incredibly hot, dense state, expanding rapidly to become the cosmos we know today. But with this revelation, an even deeper question emerged, a profound query that seemed to echo across the vastness of time itself. If the Big Bang created the universe, then what, my dear listener, created the Big Bang? This question, like a distant star, remained largely unanswered for many, many decades. Some found it almost impossible to truly grapple with, a thought experiment so profound it felt beyond the reach of human understanding. How, after all, could we possibly perceive what occurred before anything, as we define it, even began? It was a conceptual wall, a horizon beyond which our current tools of thought seemed unable to penetrate. Yet the human spirit, ever curious, ever striving, does not easily abandon such grand inquiries. And so the seeds of a new idea began to germinate, not from direct observation of the Big Bang itself, but from an unexpected comparison, a serendipitous link forged in the abstract elegance of mathematics. Mathematicians, in their tireless exploration of the universe's underlying patterns, began to notice a curious parallel between the nature of the Big Bang and a celestial body that at the time was still largely confined to the realm of theoretical physics, the enigmatic black hole. Now, the theory surrounding black holes was, for many years, deeply shrouded in mystery, an idea so extreme it challenged conventional wisdom. It wasn't until a mind of truly monumental genius, a man whose name resonates with intellectual brilliance, Albert Einstein, helped humanity to truly grasp a revolutionary concept. Through his theory of general relativity, Einstein revealed that space and time are not separate, static entities, but are in fact intricately interwoven, connected in a profound cosmic tapestry that we have come to call the fabric of space-time. Imagine this fabric not as an empty void, but as a dynamic, flexible sheet, capable of being stretched, warped, and distorted. The mathematical implications of this concept were, and still are, truly breathtaking. Einstein's equations showed that mass itself possesses the remarkable ability to bend and distort this very fabric, much like a heavy rock resting upon a taut cloth. As the rock settles, it creates an indentation, a dip in the cloth. In a similar, albeit vastly more complex, manner, massive objects in the universe, planets, stars, galaxies, subtly curve the space-time around them. This curvature is what we perceive as gravity. But what if, the mathematics began to suggest, this distortion reached an extreme, an ultimate limit? What if the mass of an object grew to an unimaginable size, its gravitational pull becoming so immense that the fabric of space-time would stretch to an infinite degree, compressing all that finite mass into a single zero-dimensional point, a point with no volume, where density becomes infinite? This, my dear listener, is the essence of a singularity, the heart of what we commonly refer to as a black hole, a place where gravity's embrace is so powerful that not even light, the fastest entity in the universe, can escape its grasp. Initially, many scientists found the idea of an infinite density utterly impossible to reconcile with their understanding of the physical world. Such an occurrence in the mathematical equations, they argued, must surely be a flaw, an anomaly that undermined the very legitimacy of general relativity. The notion of black holes, to many, seemed too fantastical, too outlandish to truly exist. Yet, as with so many groundbreaking theories, time and technological progress have a way of revealing profound truths. Over the decades, our ability to perceive the universe has grown exponentially. We have developed instruments capable of observing the subtle, yet undeniable, effects of gravitational distortion. We've gathered compelling evidence, leading us to not only accept the existence of black holes, but to confirm the presence of truly colossal entities, such as the supermassive black hole nestled at the very heart of our own Milky Way galaxy. A gravitational leviathan silently shaping the movements of billions of stars. But it was during this period of increasing acceptance, as our understanding of black holes deepened, that an even more profound and intriguing comparison was made, a theoretical bridge built between the nature of black holes and the very beginning of our universe, the Big Bang. Quantum physicists, delving into the intricate mathematics, began to notice something truly remarkable. The equations seemed to suggest that the Big Bang, with its origin from an incredibly dense hot point and subsequent rapid expansion, appeared to be in essence the inverse perspective of a black hole. Imagine a black hole as a region from which nothing, not even light, can escape, a point of no return where everything collapses inward towards a singularity. Now invert that image. What if instead of everything collapsing inward, something burst outward from a singularity, expanding rapidly to form the vastness of space and time? This startling insight led many physicists to ponder a truly mind-bending possibility. What if the creation of our universe was in fact the creation of a black hole? What if our existence, the unfolding of space-time, the very expansion of our universe that we observe, is simply us existing within the interior of a singularity, a cosmic bubble of reality? This theory suggests a breathtaking scenario, that our universe could merely be the product of an event occurring in an outside, perhaps aging universe. Imagine a colossal star in that parent's universe collapsing into a black hole, and from that very collapse, from that singularity, our own universe was born. The immense energy, the extreme conditions, the very physics of such an event could have provided the initial impetus for the Big Bang, sparking the creation of everything we know. Further compelling evidence for this extraordinary idea emerges when one considers the four-dimensional graphing of our universe's timeline. When physicists plot this cosmic evolution, it reveals a pattern, a growing expanse originating from a singularity, stretching outward, much like an infinite density would profoundly distort and stretch the fabric of space-time. This visual representation, alongside the mathematical congruence, offers a legitimate and deeply compelling answer to that perennial question about the Big Bang, what came before it. It suggests that the before might not be an empty void or an unknowable state, but rather a different kind of reality, an event within a larger cosmic framework. So as you lie quietly, perhaps allowing your eyes to gently close, consider this profound notion. We may be at this very moment expanding within the heart of a cosmic singularity, a universe born from a black hole, an intricate part of an endlessly unfolding cosmic story. Let this thought settle gently, like a soft blanket, wrapping your mind in the vast, serene mystery of our origins. As we allow that wondrous thought to gently recede, giving way to the quiet hum of cosmic possibilities, let us now turn our attention to another profound concept, one that delves even deeper into the nature of infinities and the potential for endless cosmic repetitions. The world of mathematical infinites, those boundless quantities and limitless sets, has provided a truly tremendous wellspring of insights, particularly in the realm of conceptual mathematics. Think of the groundbreaking work of George Cantor and other visionary mathematicians, whose explorations of infinity have reshaped our understanding of numbers and sets, pushing the boundaries of what we considered quantifiable. Yet, while mathematically elegant, the concept of infinites has often presented significant complications when applied to the tangible, observable world. How, for instance, could an infinite quantity exist within a finite space? Consider for a moment a simple sphere. In a purely mathematical sense, its surface is composed of an infinite number of points. Now bear with me, as this is where the theory becomes truly extraordinary. When the mathematics is meticulously worked out, in perfect theoretical precision, it suggests something truly astounding. From a single perfect sphere, one could, in theory, mathematically decompose and reassemble its points to create not just one but two perfect spheres, each with the exact same mass, size, and density as the original. This incredible mathematical feat is known as the Tarski paradox. For many years, this paradox was largely regarded as a purely abstract concept, an intellectual curiosity impossible to realize in the real physical world. After all, how could something be duplicated from nothing, or rather from an arrangement of existing parts? It seemed to defy our intuitive understanding of conservation, of matter and energy. Yet, despite these initial doubts, the mathematics itself remained undeniably correct, rigorously sound in its own theoretical domain. It wasn't until many decades later that researchers began to notice strange, compelling phenomena that hinted at the real-world applicability of such paradoxical ideas. Step into the bustling yet precisely controlled environment of the CERN Institute, a colossal underground facility where the most fundamental building blocks of our universe are meticulously probed. During its experiments involving high-energy particle collisions, where subatomic particles are smashed together at incredible speeds, scientists began to observe something truly perplexing. In these violent microscopic encounters, they noticed the creation of more particles than had initially started the interaction. It was as if new matter, new energy, was emerging from the very fabric of existence. In fact, a paper was recently published suggesting a truly mind-blowing implication that the Tarski paradox, once thought to be purely theoretical, might not only be applicable in the real world, but that many of the observed particle creation events and certain calculation discrepancies at CERN could actually serve as evidence that this phenomenon is already naturally occurring. Imagine, if you will, the profound implications of this. If this research is accurate, it could mean that our long-held theories regarding the fundamental laws of conservation of energy, the principle that energy cannot be created or destroyed, only transformed, might be incomplete, or even entirely incorrect. It suggests that new particles, new quanta of existence, could be cloned, could emerge from existing particles, naturally, spontaneously, within the dynamic dance of the subatomic realm. Now let us gently weave this astonishing discovery back into our previous contemplation. If new particles can be cloned from existing ones, if matter itself can, in a sense, replicate, and if we combine this with the already mind-bending theory that our universe might exist inside a black hole, then a truly cosmic tapestry begins to unfurl. This could very well mean that every time a new black hole is created somewhere in the vastness of an older parent universe, an entirely new universe, perhaps an imperfect but remarkably similar copy of our own, could be simultaneously brought into existence. Picture the majestic cyclical dance of cosmic creation and dissolution. A universe forms, perhaps expands and evolves for billions of years, eventually reaching a point of ultimate collapse or expansion, eventually giving rise to new black holes. Each of these black holes in turn could become the seed, the singularity from which another universe springs forth. This creates what appears to be an infinite loop, a grand, unending cycle where universes are born, mature, and eventually give rise to their own offspring, only for the cycle to begin anew. The universe forms, lives out its grand cosmic drama, eventually dies, collapses into a black hole, and then from that very collapse it restarts all over again. And here lies an even more astonishing thought, one to gently ponder as you drift towards slumber, given that the fundamental laws of physics, the unchanging principles that govern the cosmos, are believed to remain constant throughout these cycles. It would logically follow that all the factors relative to creation, the initial conditions, the fundamental constants, the very rules of existence, would remain precisely the same. This would ultimately lead to the creation of a universe that would play out almost exactly as our own. Imagine, my dear listener, the implications of this unending cosmic ballet. Could it be possible then that you, in this very moment, watching or listening to this very video, have experienced this exact sequence of events, this precise moment, over 1 trillion times already across countless cycles of existence? It's a humbling, almost surreal thought, a quiet whisper from the infinite, suggesting that our reality, our very moment, might be an echo, a repetition, in a timeless, boundless cosmic loop. Let this profound possibility settle gently within your mind, not to disturb, but to widen your perspective on the quiet immensity of all that is. As the concept of an infinite cosmic loop gently fades into the background of your consciousness, allowing for an even deeper sense of calm, let us now turn our attention to another profoundly speculative, yet mathematically robust, idea, the multiverse theory. This concept, born from the very heart of quantum physics, has a way of converting even the most optimistic individuals into profound contemplatives, inviting us to reconsider the uniqueness of our own existence. Imagine a profound question arising from the very observation of our universe. Why does our cosmos exist with these specific rules? Why these particular numbers, these precise fundamental constants that govern the laws of mathematics and physics? Why is gravity exactly this strong? Why is the speed of light precisely this value? And why are the fundamental forces balanced in such a delicate, intricate way that allows for the formation of stars, galaxies, planets, and ultimately, for life itself? Scientists and physicists, pondering the astonishing mathematical implications and the sheer improbability of our universe having formed with such finely tuned parameters, began to posit a fascinating thought experiment. The odds, they argue, of our universe spontaneously appearing with such incredibly specific, life-permitting rules are so astronomically low, so infinitesimally small, that it stretches the very boundaries of probability. It seems almost impossible for it to be a mere cosmic accident. This improbability leads to a compelling, if mind-bending, conclusion. It is far more probable that every single variation of every possible universe actually exists somewhere. If the odds of our universe being exactly as it is are so low, perhaps the solution is not that it's an improbable fluke, but that all possibilities are realized across an unimaginably vast landscape of realities. What makes this idea even more intriguing is that researchers believe they have found compelling hints, echoes of the multiverse theory, manifesting within the natural world itself, specifically within the strange and wonderful realm of quantum mechanics. Quantum mechanics, as you may know, is the science that governs the behavior of matter and energy at the most fundamental, subatomic levels. And at this level, reality behaves in ways that defy our everyday intuition. Concepts like Heisenberg's uncertainty principle, for instance, tell us that we cannot simultaneously know both the precise position and the precise momentum of a particle. There is an inherent fuzziness, an intrinsic probabilistic determination to reality at its smallest scales. Things don't just are, they might be. Furthermore, consider the phenomenon of virtual particles. These are particles that spontaneously pop into existence from empty space, exist for an infinitesimally brief moment, and then vanish again, like fleeting ghosts in the quantum void. They are a manifestation of the inherent energy fluctuations present even in a vacuum. These quantum properties, this constant dance of probabilities and ephemeral realities, suggest a universe brimming with unrealized potential, where every possible outcome of every quantum event, however small, might lead to a branching reality. If this complete probabilistic determination of quantum mechanics holds true, it could mean that every possible variation of every universe, every single decision ever made by every sentient being across all possible timelines, could more than just exist. They could be unfolding simultaneously in parallel realities, potentially even waiting to be explored, perhaps not by us, but by other versions of ourselves in other dimensions. Imagine the sheer boundless grandeur of such a concept. Every path not taken, every choice not made, every alternative history, every fleeting thought, all existing as concrete realities in their own unique pocket of the multiverse. Philosophically, this idea can lead to newer outlooks that some might find unsettling, perhaps akin to nihilism or absurdism. If every possible decision you could ever make, every triumph, every regret, every love, every loss, already exists infinitely throughout this grand tapestry of the multiverse, what then does that imply about the meaningfulness of your own choices? If every possible outcome is already real somewhere, does anything truly unique or significant remain? But let us gently reframe this contemplation, not as a source of unease, but as an invitation to profound wonder and quiet acceptance. Rather than diminishing the significance of your life, the multiverse theory can, in a strange and beautiful way, amplify it. For in this infinite cosmic dance, your experience, this unique sequence of thoughts and feelings and actions, is still profoundly real for you. It is your singular journey through one specific strand of infinite possibilities. It means that every breath you take, every connection you make, every moment you experience, is a precious, unique manifestation in this particular universe. It suggests that while other versions of you might exist, this version, this you, is experiencing this reality right now. So as you prepare to rest, allow the sheer scale of the multiverse to expand your sense of peace, not to overwhelm it. Imagine the quiet satisfaction of knowing that the universe is so rich, so abundant in its possibilities, that it can hold all permutations, all stories. Let the idea of infinite paths gently lull you, recognizing that your journey here and now is a beautiful and valid expression of existence, a single precious thread in an unimaginably vast and serene cosmic tapestry. Let this thought softly guide you, knowing that within the boundless potentials, your present moment holds its own quiet perfection. As we continue our gentle journey into the very nature of reality, and as the vastness of the multiverse settles softly in your mind, let us now explore an idea that, while initially presented as a playful thought experiment, has evolved into a legitimate point of philosophical debate. This concept, known as last Thursdayism, takes the absurdist implications inherent in the multiverse theory and stretches them even further, inviting us to question the very foundation of our perceived timeline, our memories, and even the solidity of our own existence. Imagine, if you will, the simple, yet profoundly unsettling premise: everything that currently exists in the universe, indeed the universe itself, was merely created last Thursday. This is not to say that the universe started last Thursday, but that it popped into existence last Thursday, complete with all its history, all its geological strata, all its ancient light, all its cosmic background radiation, and crucially, all of our memories, every single one of them. You might immediately find yourself wanting to argue against this notion, to insist that there is undeniable proof of time extending far beyond this arbitrary point. You might point to ancient ruins, to fossilized remains, to the distant starlight from galaxies billions of light years away, to historical records detailing events centuries ago, or even to your own vivid memories of childhood, of last year, of yesterday. Surely you would argue, these provide irrefutable evidence that the universe has been around for a much, much longer time. But here is where the ingenious and unsettling core of last Thursdayism resides. Any evidence you provide, any argument you present, can be countered by the very premise of the theory itself. The proponents of last Thursdayism would gently yet firmly explain that any such evidence is not objective proof of a pre-Thursday existence, but rather a subjective interpretation. If you were to present a video recording of an event from, say, last Wednesday, they would respond by suggesting that the recording device, the digital data it holds, and indeed every single atom comprising that evidence, merely popped into existence last Thursday, perfectly formed, already containing the illusion of a past event. This ingenious counter-argument applies to absolutely every piece of evidence one might attempt to raise. Your cherished photographs of childhood, they materialized last Thursday, perfectly crafted to give the illusion of years gone by. The geological layers of the Earth, showing millions of years of formation, they were created last Thursday, fully layered, ready to tell a fictitious tale of deep time. The light from a distant supernova, millions of light years away, reaching our telescopes today, implying a journey of millions of years. That light, along with the telescope and your memory of observing it, simply blinked into existence last Thursday, already in transit, already telling its grand illusory cosmic story. Your own memories, those intimate recollections of your past, of your loved ones, of your experiences. They too are merely part of the grand fabrication, perfectly stitched into your consciousness last Thursday, designed to provide the illusion of a life lived for many years. What makes this theory all the more mind-blowing and gives it its surprising philosophical weight is that it mathematically works. It finds its footing, its curious legitimacy, within the very concepts provided by the multiverse theory that we just explored. If, as the multiverse suggests, every conceivable variation of every possible universe can and does exist, popping into existence in an infinite cosmic tapestry, then it is perfectly plausible, mathematically speaking, that an instance of space and time like ours, one complete with an entire fabricated history, could indeed have been created as recently as last Thursday. It is simply one of the infinite possibilities. This concept ultimately argues that only the here and now, this precise moment of your experience, is truly real. Everything else, every memory, every historical record, every distant star, is merely a sophisticated, perfectly consistent illusion, a stage set for your immediate perception. And if only the here and now is real, and all else could be a recent fabrication, it begs an even deeper, more personal question. Is anything we have ever experienced, anything we believe to be our past, actually real? Or is it all merely the product of a universe that for us just popped into existence last Thursday? And if that is the case, then perhaps only you could ever truly know that you exist, a solitary consciousness within a recently created, self-consistent, yet profoundly mysterious reality. This can be a startling, even unsettling thought, but let us not dwell on its potentially disquieting implications. Instead, let us gently pivot, allowing this theory to serve as a profound invitation, a quiet reminder to truly immerse ourselves in the present moment. If the past is a story and the future is an unfolding mystery, then the now is the only true reality we ever genuinely inhabit. Last Thursdayism, in its strange, counterintuitive way, encourages a deep appreciation for the immediate, for the sensory richness of your present experience, for the quiet breath you take right now. It is a philosophy that, rather than erasing meaning, centers it precisely in the vivid, undeniable reality of this very instant. So, as you prepare to cross the threshold into the gentle embrace of sleep, let this quiet contemplation settle within you. Whether the universe is ancient or newly born, whether your memories span decades or mere days, the beauty of your present moment remains. Allow the thoughts of the vastness, the mystery, and the quiet unfolding of existence to serve as a calming backdrop, a gentle current to carry you effortlessly towards a deep and restorative rest. Release any need for certainty, and instead embrace the soft wonder of not knowing, of simply being. Given these truly mind-blowing theories, it is quite natural for your mind to be teeming with questions, with a sense of quiet awe and wonder when it comes to the nature of ourselves and the vast, beautiful universe we inhabit. But for now, as the gentle rhythm of these cosmic tales unwinds, let those questions softly recede, like distant echoes in the quiet expanse of space. There is no need to grasp, no need to seek answers in this moment. Instead, allow the sheer immensity of these ideas to simply be a soothing presence in the background of your awareness. As you drift now, let the notion of universes born from black holes, of endless cosmic cycles, of infinite realities, and of time itself being a malleable story, become a gentle lullaby. These are not concepts to be vigorously debated, but rather profound whispers from the cosmos, inviting your mind to expand, to relax, and to surrender to the peaceful unknown. The universe is a place of boundless mystery, and within that mystery lies a profound sense of calm, a spaciousness that can hold all possibilities, all theories, without needing to resolve them. Let your breathing become softer, deeper, a gentle wave ebbing and flowing with the quiet expanse of the night. Feel the gentle weight of your body, supported and at ease. Release any lingering thoughts, allowing them to float away like clouds in a serene sky. Tonight, you are a part of this grand cosmic story, an intricate thread in the fabric of existence. And just as the universe finds its rhythm in expansion and contraction, in creation and dissolution, so too does your body seek its natural rhythm in rest and rejuvenation. Thank you for joining us on this tranquil journey through the universe's deepest mysteries. May these quiet contemplations guide you now into a truly peaceful and restorative sleep. Let the vastness of the cosmos cradle you, and may your dreams be filled with a serene sense of wonder, knowing that you are, in every moment, a part of something truly magnificent. Sleep now, deeply and peacefully.